Welcome, this is 8.1. How can you use distributive property to multiply binomials? Well, my first question for you would be, what are binomials? So let's take a quick look at these. Binomials are two-term polynomials. A polynomial is a sum of monomials. You might say, what the heck is a monomial? Okay, let's go that far back then. A monomial is a number. Could be 3, could be 5, could be 35, it's a number, or it's a variable, x, y, x squared, y, yz, could be variables, the product of numbers and variables raised to powers. So here's product, here's products, here's product, here's even a product that you might not be aware is a product, 1/4 times x squared, y. We actually simplify that to write it as x squared y over 4. Okay, so those are monomials. Notice there's no variables on the bottom, only numbers on the bottom. There's whole numbers. There can be variables with an exponent, but there's no variables in the exponent. So that's the first thing. So a binomial is a two-term polynomial, and polynomials are a sum of monomials or binomials. So basically, to have two terms, you would have to have a plus between two items or a minus. Those items could be like terms, or else you would add them and have a monomial. So you could have like x squared plus 7, 2xy plus 3x. As long as they're variables are not identical, then they couldn't be combined, and that would be two terms, one plus or minus between them, and that constitutes a binomial. Okay? So now we're going to look at how we use the distributive property to multiply these. First way, which is easiest in class to do, but I'll show you it here, is to use the tiles, the algebra tiles. Now, if you've used these before in the room, you know the big square one? It's usually colored like blue or yellow, sometimes green. That's the x squared. So if we take x plus 3, we line up the length of that x, the length of this x, it's building an x squared, because x times x is x squared. X times 2x would end up being 2 of those x squareds. Now, 3 times x will be 3x. Those long skinny ones are x's. 3 times this x will be 3x. And 1 times x will be another x. And then 1 times 3 would be 3. If you've used the algebra tiles, you've seen this. You know what they mean, so there would be 2x squared. You would write it as 2x squared. 1, 2, 3, 4, 5, 6, 7 x's. And 3 that are just a regular size, no x involved. So that would be the answer there. You can use tiles for your multiplication. Another way, it's what a lot of students have nicknamed clamshell. Your main thing in multiplying binomials is you need to make sure this term multiplies by each of these and this term multiplies by each of these. So really it's not about the multiplying, it's about the organizing of showing that you've done that. So here's what a lot of students will do. They'll draw a line from the first one to both of those. When they do that, they need to multiply it. Don't draw all your lines first. So 2x times x would be 2x squared. 2x times 3 would be positive 6x. Now you need to draw a line from this one to each of those and multiply that. 1 times x, don't line it up with x squared. It's not an x squared. Line it up with the x. 1 times x is 1x. 1 times 3 is 3. Now add all those together. 2x squared. 6x and 1x is 7x. And 3. So there is that way to do it. That's called clamshell because it looks like a clamshell. Or some people will say like a crawdad pincher. But clamshell's been the most popular. Okay, FOIL is a very popular one. You can find it in textbooks. All that FOIL is each of these letters stand for first. First times first is 36x squared. 12x times 3x. O stands for outside. Outside is this one and that one. 12x times 6 is 72x. Inside is this one. Negative 5 times 3x is negative 15x. And last would be this one and that one. Now you've made sure that this multiplies by each of these, this multiplies by each of these, this multiplies by each of these. Okay? So negative 5 times 6 is negative 30. Now your two middle terms, if they're alike, combine them. So we have 36x squared, 72 minus 15 would be 57x. My 7 got crazy there, sorry. And minus 30. That's your final answer. Okay? Next one is a very popular way that I've seen students do it. You build a box. Under this one, you can just go ahead and draw your 2 by 2 box. And then you write this one in the front of the box. 6x times 2x, put the answer right there, 12x squared. 6x times 1 is 6x. 2x times negative 4 is negative 8x. And negative 4 times 1 would be negative 4. Now, if you're going to have like terms, they'll be diagonal. So we bring down our answer, 12x squared. Negative 8x and a positive 6x would result in negative 2x, and then bring your negative 4 out. Okay, so that's the box method. Several different ways. You don't need to know how to do them all. You need to do one really efficiently. Now, here's some special case multiplication. Is there a pattern that you could look at if these were squared? So this is a perfect square. Well, let's see the pattern. Let's just do the box method. We're really just looking for a pattern in the answer. 2x plus 5. 4x squared. 10x. 10x and 25. 4x squared plus 20x plus 25. So let's look back at this. Could you have found 4x squared by looking at the 2x and knowing that it was squared? Absolutely. You just square this. 2x squared is 4x squared. 5 squared is 25. So the only tricky part here is how do you find the middle term? Well, 5 times 2 is 10x. If you think about it, you've got two middle terms because it's squared. So 2x times 5 is 10x times 2 is the 20x. So it's 2 times 10x, or times these two. Okay? Now watch this one. It's almost the same. So if we follow this pattern here of squaring the first, squaring the last, and then bringing in the middle term, there's only one thing difference. We'd have 2x squared. Make sure you square the 2 with that. You have a plus 5 squared, from the back. You need to bring this sign into your 2 times 10x. Remember, it won't affect the back term because it's a negative 5 times negative 5. But when you go 2x times negative 5, that's negative 10x, and you have 2 of them. So your final answer would be 4x squared minus 20x plus 25. You can always FOIL or box these out. You don't need to memorize the shortcuts. Last one is a special case scenario. Let's FOIL this one. First, outside, inside, last. First would be 2x times 2x. That's 4x squared. Outside would be a plus 10x. Inside happens to be a minus 10x. And last is a negative 25. Do you notice how those two cancel? When you see a binomial and what we call the conjugate of the binomial, in other words, the opposite sign in the middle, then you know that you have the difference of two squares, because the answer is a square minus a square. 4x squared minus 25. I would expect you, when you see this, to do the shortcut. I don't want to see you have to work it out every time. If you see that they're opposites, you know it's the square of the first one minus the square of the second one. Work it out for me until you see that it's always going to work, and then you'll have that.